Hello everyone, and welcome back to another GIS mathematics video. And in this video, we're going to continue our discussion talking about lines by talking about perpendicular lines. So if you're watching these videos in order, you hopefully are coming off of our discussion on parallel lines, where we talked about what it means for a line to be parallel to another line. And we said that it's because they have the same slope. And now let's talk about what it means for lines to be perpendicular. So I want to be upfront here and clarify that there is a difference between two lines intersecting each other and two lines being perpendicular. And hopefully that will be clear by the end of this video. So what I've done is I've constructed two lines here that I'm going to tell you are perpendicular to each other. And hopefully you can see graphically that that appears to be the case. And so the big thing with being perpendicular here is that not only do they have to intersect, which is something that parallel lines will never do, but perpendicular lines not only do they have to intersect, but they have to intersect at what's called a right angle, right? And we would normally see that designated as a little square here in the corner, designating that these two lines intersect at a right angle. So let's say that. For lines to be perpendicular, they must intersect at a 90-degree angle. Now I'm not going to go through the proof of why what I'm about to tell you is true, but looking at the equations, we can figure out if they're perpendicular by a very simple test. So let's go ahead just like we did before and let's rewrite our equations. Y equals 2x plus 1 here, and y equals negative 1/2 x plus 8. Let's give ourselves a little bit more space here. Let's move this equation down just a little. Y equals negative 1/2 x plus 8. So let's look at the slopes just like we did last time, right? We looked at the slope here and we looked at the slope here, and we found that in order for the lines to be parallel, the slopes had to be the same. Well, in order for the lines to be perpendicular, and hopefully we're not introducing any new terminology for you, they have to be negative inverses of each other, right? The inverse of 2 is a half. The negative inverse would be negative 1/2. So hopefully this makes sense that the slopes are negative inverses. Negative inverses of each other. And to put that in sort of terms that are a little more abstract here, right? In this case, we have 2 and negative 1/2. But if we were to put that in algebraic terms, right, negative inverse would be x compared to negative 1 over x, right? The inverse of the negative inverse of 3/4 would be negative 4/3, and vice versa. Now the minus sign can go on either side, right? The minus sign, it could be negative x's inverse would be 1 over x, negative 3/4 inverse would be 4/3. But again, the idea is that they're negative inverses of each other. And put another way, right? The product of the slopes is negative 1. Right, the product of the slopes is negative 1. So what does that mean in this scenario here? right? So it would mean that 2 times 1, I keep forgetting the negative, 2 times negative 1/2. And what's that going to be equal to? Well, the 2 here would cancel out with the 2 here, and you'd be left with a negative 1, right? So all three of these things indicate that these lines would be perpendicular. The first is if you're told that they intersect at 90 degrees, which we would be by this little square here. If the slopes are negative inverses of each other, right? 2 is the negative inverse of negative 1/2. Or if the product of the slopes is negative 1. So if you actually multiply the two slopes together and you get negative 1. So hopefully this makes sense. Again, this introduced the term negative inverse. Hopefully you understood that. If any of this seemed confusing, I would encourage you to pause the video, go back, rewatch the part you're confused about, and as always, please reach out. Thank you.